So let's get started. I'm Kaz. I'm a developer advocate from the Cloud AI team based in Tokyo, and focusing on ADK Agent Development Kit from Google and also vector search. I already done the vector search workshop. It was like 1 week or 2 weeks ago. And this week, today, I'd like to introduce what is ADK Bidi-Streaming. That allows you to build an AI agent that understands the voice and image from user and responds to the user by using voice directly without using any speech-to-text or text-to-speech model. It's a so-called native audio model it uses. Okay, so let's get started. So what is bidirectional streaming? Bidirectional streaming is a two-way communications, like you're seeing on this diagram. So usually in the past, most of the chat AI applications is not bi-directional streaming. It's a one-way, or maybe people would call it a half duplex communications, where user will be sending the message to the AI, and the AI will be responding to that. And if the response from the AI is so long, usually it's really hard to interrupt that, especially in the voice communications. For the AI applications like a ChatGPT or Gemini, there's some stop button, so you can force interrupting or stopping the AI response. But with voice AI application, it's really important to have the bidirectional streaming communications, so that the user can anytime interrupt to the AI's response and start another discussions or another questions. So with bidirectional streaming, so you can easily have the user experience just like having the real-time conversations with the another person. And the ADK Agent Development Kit is an open source framework from Google that allows you to quickly build and demount agent systems by using Gemini or any other third-party models. Because this ADK is an open source project, it's not dedicated for the Google's cloud products like a Vertex AI, Gemini API, but it also supports the other models like OpenAI models and third-party models or open models. But if you use the Gemini, then because Gemini provides a live API, that is the native audio model product, so it allows you to build an ADK agent that has the full duplex, the bidirectional streaming capability for the voice and image communication. That would usually takes the like a few months, but by using ADK Bidi, you can shorten the period into it like in this case, I'd like to show that everything's within like 50 minutes or so. Usually, it takes so long times to build the productions, the audio AI products, because you have to set up every bidirectional streaming communication infrastructure like a WebSocket management, or the handling the audio logging between the client side JavaScript or TypeScript client audio handling and the server side audio handling, interruption handling and session state. Everything's are developers' responsibility. So that makes it really hard to build production voice AI applications. But ADK Bidi provides the encapsulated framework, asynchronous framework that is available for the developers quickly, so that it's much easier and faster to build in the voice AI agents. And as I mentioned, the ADK Bidi is kind of the wrapper or the abstract layer for the underlying layer that is the Gemini Live API. So it's possible that you can directly use the Gemini Live API to build the voice AI agent. But if you want to really want to build a production quality service, there are many things you have to build by yourself with the raw Live API. For example, Gemini Live API doesn't provide any agent framework. So if you want to have some agentic functionality, like if you want to build an agentic RAG systems, you have to have the agent framework defined by yourself. And also for the RAG part, like making a search on the search engines or vector search databases, you have to build around the tool execution. Live API itself just responds with a hint of the tool call. So it's your responsibility to actually make a tool call against the vector search or search systems also. But by using the ADK Bidi-Streaming, because ADK has the full set of the agentic framework with including the tool use API, so all you have to do is just a simple defining just a simple the tool for accessing the databases or search engines. That's it. So ADK Bidi automatically calls your tool definition, tool function, and makes the search query to get the result back to the native audio model. That's so easy. And also sometimes really hard to provide the stability, especially for the Bidi-Streaming or real-time communication applications. Because, for example, if you're using Live API directly, usually the WebSocket connection with the API is closed for every 10 minutes or so. And the session content will be gone because the Live API session is a transient or temporary session. So it maintains the old session information in the memory while it has the WebSocket connection, but it will be disconnected every 10 minutes or so. So you have to handle those session resumption or session persistence by yourself. But ADK provides the session automatic reconnection, transparent reconnection, and session resumption functionality. So you can just let the ADK handle all those complex things for the session management and the connection management. ADK Bidi provides the asynchronous event model with its the very useful handy framework on the APIs, so you can just call it. And also the ADK provides the persistence for the session informations by using the SQL databases or the data store from the Vertex AI, or you can choose to use the memory session store for the debugging. So you can choose one of the variety of the options for the session persistence storage. So that's the difference between the low live API and the ADK Bidi-Streaming. And by using the ADK Bidi, you can build an voice AI applications for various verticals or use cases like e-commerce or customer service, field service, healthcare, or financial. And let me show some interesting example that is called Shopper's Concierge. That is built with the ADK Bidi-Streaming combined with the Vertex AI Vector Search 2 product. That is the product I have explained the other day. So let me show the video.
Hello, I'm Shopper's
I
Concierge.
suppose you are hearing the voice from the demos. If you're not, please let me know.
And I can help you explore our e-commerce site, which has about 10 million items. What can I help you with today?
Can you find cups with dancing people?
Starting search for cups with dancing people. Search completed. Found 88 items for cups. The top 3 items are the Kilncraft Dancing Chorus Line mug, Halloween Dancing Ballet Skeleton mug, and the Vintage Favelina Dancers mugs. You can refine your search or let me know if you'd like more information on a deep research.
Now I'd like to find a birthday present for my 10 years old son.
I can help with that. What kind of things does your son enjoy?
Toys.
Starting search for toys for your 10-year-old son. Search completed. Found 75 items for toys. The top 3 items are the Spider Toy Walkie-Talkies, the Advent Calendar 2024 Fidget Toys, and the 10-in-1 Electric Building Toys. Let me know if you'd like to refine your search or start a deep research.
Deep research.
Would you like me to start a deep research on
Yes.
toys for your... Starting deep research for toys for your 10-year-old son. Found 5 item categories: STEM building kits, action figures and collectibles, outdoor adventure gear, board games and strategy games, and creative and craft kits. Starting deep research for birthday presents for your 10-year-old son, I found 5 item categories: STEM building kits, action figures and collectibles, outdoor adventure gear. The deep research has finished. Concierge's pick has been sent, featuring the top items from the deep research results. Would you like to hear about any of the categories or?
So that was the demo. So this is I spent like 2 weeks or 3 weeks, maybe 2 weeks to build this demo. So for today, we are not going to build this entire things. We are just going to show a demo that enables the real-time voice communications. But if you use the Bidi-Streaming, you can build some the production quality voice application, AI applications like this one. Oh, I got the question. So is the model returning voice to or text and text to speech was used? Yeah, I already discussed about that. But the ADK Bidi supports the audio transcription. So both the user voice and the AI voice will be transcribed in real time. That's the answer. Okay, let me go back to the material. So I show the demo. And this workshop contains the, there's another developer guide. So if you're interested in using the Bidi-Streaming API by looking at this workshop, the real resource is here, ADK Bidi-Streaming Developers Guide. So if you go to the page, there are tons of the documentations and materials to learn about the details of the Bidi-Streaming. So yeah, this could be super useful for when you are building the production Bidi-Streaming applications by yourself. Okay, let's get started with the actual demo building process. So we'll be building the small sample applications that accepts text, audio, and image input, responds with streaming text or natural speech, handle interruptions naturally, and it can call tools like Google Search. So let me do that. This is the final image of the demo. And this workshop includes the total 8 steps, but maybe because we only have like 35 or 40 minutes or so, maybe I can skip some of the not so important steps. And this is the steps where you set up the development environment. You can use the Cloud Shell editor, or you can choose to use other environments such as the what is that, cloud workstations or GCE instance or anything you want to use. Okay, this is the first steps to download the source code I have prepared. I already downloaded the source code to my cloud workstation editor, so there's already a source code available. And to use any kind of the Gemini API, we'll be using Gemini Live API for the audio model. Or if you want to use any other Gemini APIs, you have to set up the environment, the variables, set up in the API key or the GCP Google Cloud project. So in this case, I have set up the Google Cloud project. This is my own GCP project, so you can set it to your own project ID, and with the location and set using the Vertex AI. So Live API has 2 versions. One is the Vertex AI Gemini Live API. Another is the Google AI Gemini Live API, Gemini Live API, or maybe just a Gemini Live API. So we provide 2 different types of the APIs for the similar or same model. You can get started with the Gemini API so that you don't have to set up the Google Cloud account or billing or credit card or something. It takes some time because you have to sign up with all the terms of services or press many buttons to enable the APIs. So if you really want to just try out the Gemini API or Live API, easiest way is to use the Google AI Studio and use the Gemini API. That's the easiest. But this time I will show how you can use the API using the Vertex AI, which is the Google Cloud AI platform. In that case, you specify the project IDs and the locations and the this flag back. What are the pros and cons versus STT, LLM, TTS? So the question is about, so as I mentioned, this the Bidi-Streaming doesn't use any speech to text, STT, or TTS, text to speech. The pros is doing the benefit of using the native audio model that doesn't require any STT or TTS is that latency and more natural conversations, as I have shown in the demonstration. So STT or TTS always requires some latency, so it feels like some lag happening between the AI and the user. So it can be shortened as much as possible. And also another benefit is also I will not show how it works for this demo, but there's a couple of the advanced functionalities of the native audio models, such as the affective dialogue. Affective dialogue means that it can sense the tone of your voice, like emotion understanding by tone of your voice. So you can try that after this workshop by yourself by opting the affective dialogue option, so that and you can talk to the AI in in angry voice or sad voice. What's happening here? What are you doing now? Then native audio model can detect your tone in your voice and do the reasoning how to strategically respond to that angry voice, angry person. So try to how to put it. Try to not control your emotion, but try not to be rude to your the message or request. That's the some things you cannot find any existing text-based LLM. But the downside of using the native audio model is that you can find it easily that the audio transcription is needed. Audio transcription is provided by the ADK Bidi-Streaming and Live API as a default functionality, but you will be easily noticing that the quality of the audio transcription is lower than the LLMs. So sometimes the transcriptions may have the misunderstanding of the AI voice or user voice because the Gemini teams have to use the separate smaller model only for the audio transcription. That's the downside. Yeah, so transcription quality is a little bit lower than the understanding quality of the LLM itself. Okay. So that was the questions answered for the questions. And after you install the required packages like the ADK, Google ADK, and it actually includes the Fast API. ADK includes the Fast API. That is the popular web framework for the WebSocket the applications. And the UVCon that is used by the Fast API. And for loading the environment variables. So those are the required packages to run this demo. And here's the architecture overview of the entire ADK Bidi-Streaming setup. So all you have to do is you prepare for the blueprint, like the WebSocket server using the Fast API that provides the communications, manages the communications with the client, the web browser or mobile app. And also it calls the ADK Bidi-Streaming API. And another thing you have to do is define an agent for ADK, and that's it. So everything else, like handling the queuing of the incoming messages or the voice chunks, or the asynchronous streaming inside the ADK, or communication with the Google Live API, WebSocket communication, those are all taken care by the ADK itself. So you don't have to care about those details much. Okay, let me get started with the step 1. Maybe this is the first the demo. Let me find that. It's just copying the simple main.py code and run the server, the fast API server. So at this time, it's just set up the first API, and that's all. So it doesn't have any functionality for the voice communications or so. So this is the first the setups where if you type any messages, it's just echo server. It doesn't have any agentic capability at all. It's just a first API that responds to the user's request by echoing, is sending back the same messages. Take a looking at the how it's defined. It's just a plain usual fast API server where you define the WebSocket endpoint like /ws that takes the connections from the client. And you'd have, as usual, you would have the infinite loop that keeps taking the WebSocket message, and it's just sending back the same message back to the client. That's it. It doesn't include any ADK related code at this time yet. So it's just echoing back. So I'll skip. So by the way, this demo has the pretty cool event console UI written with the JavaScript. So this demo could be used for the debugging your Bidi-Streaming applications by looking at those the events sent from the ADK. So for example, this is the actual text messages sent back from the server. It includes the content, prods, and the text messages. So you can use this as for the debugging. Turn complete is the flag that represents this is the end of the message from the agent. So you can use it for updating UI to show the conversation states. And also this demo has the various other the event console functionality to show the various event types like a text, audio, transcription, tool call, and so on. I can skip the WebSocket part and defining the agent. So now we will be defining the agent. Where's the does it already have the agent? Sorry. Okay. Let me check the code. Yeah, it already have the agent. Yes. It already have the agent definition. That is the agent defined for the ADK. That has name, and that defines the live API live model. This is the nature of an audio model I have been mentioning. So it has the capability of the understanding your voice directly. And this is the very simple instructions for the model. You are a helpful AI assistant. You can use the Google search to find current information. So as I mentioned, ADK handles all the tool calls itself. So it's just specifying 2 lines. You are importing Google search built-in tool and specifying Google search as one of the tools for the agent. And that's it. So with those 2 lines, you can let the agent call the Google search immediately where to answer the questions from the user and send back the result to the user. So this is very handy, useful, powerful functionality. A question, how does the live API handle the delay when calling tools for the response? This is a great question, and this could be advanced the questions in a way. So for the very fast tool like a Google search, you'll be seeing how it works in demo. But it's super fast. Like Google search can respond within like a 0.5 seconds, like 5 milliseconds. So you don't have to think about the latency much. But if you want to define your own tool, that takes like 10 seconds or 20 seconds or 30 seconds or minutes to respond with the final answer to the agent. Then there's a great the API called streaming tool in ADK. Streaming tool allows you to your tools to sending back the intermediate status to the agent in real time. So you might remember that with the first demo I have shown, the demo video of the Shopper's Concierge. So the agent was actually sharing the intermediate status. Now I'm searching with the 3 million items, blah, blah, blah. And then it stops talking and, oh, I got the search result now. Here's the items for the kids or something like that. So that was implemented with the streaming tool that can keep getting the intermediate results from the long-running tool and sharing the status with the user is voice. Another question, would this be suitable to use for voice input output for an agentic app that is built on another platform or one where it already exists, but it uses VIDI for voice input? Yeah. For example, because the ADK itself is an open source, and also you can call Gemini Live API from anywhere in the world, like from AWS or your local environment. For example, you can, if you have any existing AWS applications, you can use ADK inside your ADK AWS applications and call the Gemini API. You can do that to use the VIDI streaming functionality. How about tools calls? This is very important with Gemini Live. The control over tools call is not as reliable as STT. That's another great question. So yeah, if you really want to have the full control over the tool calls, especially for the production or mission critical use cases, I would recommend to use the Live API, not non-native Live API. There's another previous versions of the Live API models that supports the so-called, what was that? Cascade audio model that has the STT, LLM, and TTS inside the model. So that model is more stable for the tool calls. Yeah, it is true that the native audio model sometimes it's not so easy to have the 100% accuracy on controlling the tool calls. That is true. Yeah. Okay, going back to the I think I have only like 15 minutes, so I can skip the not so important part. ADK tool, I have explained the Google search tools. Yeah, I just explained about this, but there's two types of the models. Native audio models, this provides the shorter latency, more natural conversations with the affection. What is that? Affection that understands the emotion, that senses the emotion from the voice tone. But if you really want to provide a very the robust and stable the workflow for calling the tools, another option is to use the half cascade models, and ADK VIDI supports both of them. You can choose one of those models. This is the links to the pages where you can find the latest model ID for those native audio model. So this is the step 3, where you want where you are defining the entire structure for the VIDI streaming applications. So it's not so hard. You can just set up the applications as the application initializations, where you define the agent as we have seen already. And you create a session, you create a runner. This is the orchestrator or runner for your agent running in the runtime environment. And then for each user connections, every time a user connects with the WebSocket, you create the session, ADK session, and you create a LAN config object that provides the options, that specifies the configurations and options for using the Live API models. and you create the live request queue for buffering the incoming request like a voice and the text, and you start the event loop that keeps generating the new the messages coming from the agent. And phase 3 is the actual loop inside the run live event loop. So there's an upstream flow and downstream flow running in parallel or running in concurrent, so that you can implement the two-way real-time streaming flow. And as soon as you finishes the sessions, you need to explicitly close the live request queue. That means you are shutting down the session with the live API and cleaning all the session informations inside the ADK memory, and save the session history on the persistent storage. So that is super important to terminate the session correctly. Session initialization. Run config defines the configurations for the what kind of the functionalities you want to use, like a transcription. Well, I got the question. For live calls, where latency is critical, does ADK has any latency overheads compared to using the Gemini API directly? Actually, this is a great question. And ADK is explicitly designed to almost zero latency. So it's transparent, but it has the very useful handy functionality like a session resumption. So you don't have to worried about the additional latency by ADK. There's almost no latency. And by using the run config, this is the cheat sheet for using the run config for the live API. There are so many functionalities you can turn on or turn off, like response modalities is how agent should be responding in text or audio, or session resumption, as I mentioned. I want to mention explain this, but there's also another function called context window compression, just like the context compression is available in the decoding agents. So that you can compress the context and keep going on with the additional time duration of the live session. Or you can specify maximum amount of the LLM calls to have the budget management on the API the LLM calls. You can even save the audio data into the Google Cloud storage and so on. I got a question. Can it be used in a healthcare setting? If so, kindly share some light. Yeah. But actually, there's not much part where dependent on the healthcare usage. Maybe the reliability of the model could be the one things you might care for the healthcare use cases. For example, if you are using the applications for very mission critical things, like a HIPAA, maybe I have to take it back. Usually the Google Cloud entirely supports the HIPAA compliant, but I'm not sure about if each native audio model supports the HIPAA or not, because I'm not that I don't have much knowledge about HIPAA. But in Google Cloud General, you can search Google Cloud HIPAA to understand what's the compliance, HIPAA compliance on the Google Cloud. But I'm not sure about the model behavior also. Okay, so this is the run config, the configurations you can set with the live sessions. And also another important API is the live request queue, where this is the funnel of all the messages from the user, incoming upstream the messaging, like the text, what should I say? Yes, the native audio model can take the audio messages or text messages. But the native audio model can respond only in the audio. So that's the native audio model's capability. But you can use the audio transcriptions to show the text response on the UI. But anyway, the live request queue will be taking all the messages, text messages, or audio stream or the activity signals. This is you need to use this activity control APIs only when you want to use the push to talk kind of UI, like where you have the push button on the UI to let the user talk to the microphone only when they are pressing the push button. You can control that. Otherwise, by default, the model supports so-called the voice audio detection, voice activity detection, or VAD. So usually the agent automatically detects when user start talking, during the talking and finish talking. And after detecting the finish of the talk, then agent starts responding back. So usually you don't have to think about the VAD yourself. But for some use cases, like users are in the noisy environment, or users have the multiple the users we are sharing the same microphones. In those specific use cases, you may want to use this activity signal to explicitly control the voice activity. So I got the questions. Can we run this lab in Colab? No, this sample code is designed for running inside the the Linux runtime only. So you can use the Cloud Shell editor or the Cloud Workstation to run this source code, demo code. So live request queue is the API for collecting all the incoming messages from the user. Looking like that. This is the diagram that explains the difference between the ADK session and the live API session. As I mentioned, the live API session is ephemeral, temporal session that will be deleted as soon as you lose the WebSocket connection with live API. So you cannot rely on that as the persistent session storage. So in contrary, ADK session supports the persistence. So that's another benefit you could get from the ADK, where it supports the memory persistence or database persistence or data store persistence. So you can store the conversation history with the user for like days or weeks or years. Okay. Maybe I can skip the not so important part. There's another cheat sheet. Yeah, there's another cheat sheet. This is the diagram that explains how the event loop works. So for the all the outgoing messages from agent to user, the run live method will be generating the events. And each event represents the text message or audio chunk or transcription message or metadata message or tool call, status, or error events. So you have to write some event handler inside a Python code or a TypeScript or JavaScript client code. In this demo case, it uses JavaScript code to handle the event handling. But so that you can show the messages on the UI or handle the flags like a partial message or a complete messages or interruption is happening. That kind of the events can be properly handled by the client or the inside the server. Okay, well, actually, let me try the last one. Yeah, skipping the intermediate steps and the last one. Step 8 is the last one, so that I can go back to the demo and copying the. Oh, this is not good. Copying the last final code and run the server again. Yeah, it's working. And reloading the demo. So let me try the demo. Hello? Oh, it's not working? Hello?
Hello, I'm here to help. What seems to be the problem?
What's the time in Tokyo now?
The current time in Tokyo, Japan is 10:44 a.m.
What's the latest price of gold?
As of recently, the spot price of gold has been around 4,990 per ounce. Prices can change quickly though. Is there a specific weight or currency you're interested in?
What do you see in the image?
I see a man with graying hair and a beard, wearing glasses and a blue t-shirt. He's looking towards the camera. Behind him, there's what looks like a shelving unit with some items on it.
こんにちは。
こんにちは。お元気ですか？
今何時ですか？
東京は今、10時午前10時44分ですよ。
So just like that. So you've seen many different functionalities, like the real-time conversation and real-time tool call. What else? Real-time image understanding and multilingual support. So everything is done with the ADK Bidi-Streaming. And let me show some important functionality. So it has the image, audio and image understanding capabilities. And you have to send the audio in 16-bit PCM, and it gives back the 16-bit PCM data as the output. And the image understanding, it's up to 1 frame per second. So it's not really a video understanding. It's a sequential image understanding. But please be careful about the context usage, as each image takes so much amount of the context. So I usually use the single static image to build my demos so that it can suppress the context usage. Okay, I got some questions. Oh, thank you so much for all the positive feedback. Yeah, language switching actually takes no time. The single model can understand multiple languages. But that the chirp voice for Japanese, I'm not sure. Actually, I don't know if they share the same the chirp voice model with this model. Yeah, it's possible, but yeah, this is actually a standalone model trend itself. So, yeah, I agree that it sounded very similar to the existing other chirp model and Gemini, the audio models. Does the agent learn by itself, or do we need to feed some data? You don't have to feed any data unless you want to do some grounding or some things. So you don't have to do any pre-training or anything. What the users are charged, what is the pricing model? It's based on the 100% token usage. So there's a pricing chart on the Gemini Live API documentation page where it defines the how much does it cost on each token, input token and output token. Okay. So what else? What else do I have? I think that's it. Yeah, the wrap up. So I'd like to recap the important components in the ADK Bidi-Streaming. One is the agent. Yeah, you can define the agent in ADK as usual. And then you can use the session service that could be persisted so that you can store those conversation history stored on the Vertex AI data store or the SQL databases. And you can use the runner to run the agent inside its runtime to generate the event from the agent continuously. You can configure various functionality of the Live API from with the run config object. You can use the Live request queue as the funnel for all the incoming messages and data. Run live is the function for the asynchronous generator that is the streaming of events. And using the methods like send real time or send content, you can send the text or the audio or images to the agent in real time. Okay, so that was the short introduction of the API. Any other questions? Oh, I got questions. Is there any way we can get the output in, what is that AKW? What KW stands for? Yeah, please explain what is a HKW, not kilowatt, right? Sorry, I don't know that. So Dimitri asks, that last demo, was that in the step 3? The last demo was step 8. So if you directly jump into the final demo, just copy the step 8 main.py. How can this app or agent be tested quantitatively? How to prevent the hallucinations here? That's a great question. And evaluating on the hallucinations could be relatively easier because you can just use the audio transcriptions and combine it with the evaluation tools, such as ADK provides the evaluations, the functionality, and also Vertex AI provides the evaluation service, Vertex AI evaluation model evaluation or something, where you can use the what is that? Using the LLMs to evaluate LLM techniques. You can define the instructions for the evaluating LLM to what would be the matrix for evaluating the outputs, and passing the audio transcriptions output to that evaluation service will work for quantitatively working the result. For example, if you are defining a shop assistant, the audio agent, then you can use the audio transcriptions output to evaluate if the shop assistant properly responding to the user answer to the user's request as expected or not. Yeah, you can quantify that. And but the harder problem is the how to evaluate the, for example, to call or the how to evaluate the voice itself, like how does it sound? It's more qualitative things you have to evaluate. So it could be, you have to think about that, how to evaluate that by yourself. Okay, now like now the model is giving the output in 24 kW is showed in the previous way. What's kW? Kilohertz. Okay. Yes. So the native audio model takes the 16 kilohertz for the input audio, and outputs audio is sampling rate is 24. Somehow they use different sampling rates for the input and output, 16 and 24 kilohertz. Are there any domain-specific guardrails? This is another great question. Like healthcare, again, this could be a guardrailing. There's no hard guardrailing embedded in the native audio model itself, so you can build that by yourself by using the audio transcription. For example, you could have the another Gemini fast, smaller model like a Gemini 2.5 flash light, kind of the small model, to keep watching the output from the audio transcriptions to do the guardrailing in real time. But maybe it's really hard to, stop what the agent is saying in real time. But at least we can monitor that and monitor the trajectory is not going into the wrong direction or not. Yeah, just like the evaluations I mentioned. And also, as usual, you may try different approaches for the instructions or prompting. That's the things you can do with the guardrailing. If I wanted to log transcript, what would be the good way to do so without introducing I/O latency? Because the transcriptions is just a text, it doesn't involve any latency, whether you are storing on local storage or recording using the cloud logging, the functionality, or just cloud storage for storing loggings. In any ways, I don't think it has any major latencies. Okay, yeah, maybe you would use the logging library connected to the CRUD logging service so that you can use the CRUD logging console to monitor all the events and transcriptions. Well, the recording of this session. Oh, yeah. Thank you. I'm transcribing this call with my. Okay, thank you. When interacting with the agent, if it outputs odd pronunciation errors, can we tune somehow to correct? Unfortunately, at this time, it doesn't provide any tuning configurations or tuning method for the pronunciations. Unfortunately, actually, if you try the model with the languages other than English, you'd sometimes find the some mispronunciations. For example, I have been trying the Japanese with the model, but I sometimes notice that there's some misreading of the Chinese characters also. But unfortunately, there's no way to tune that at this time. Maybe you can write some instructions or prompts to use some specific, safe statements, like when the customer asks for this request, always responds in this particular sentence, so that you can avoid to have the unexpected pronunciations or sentences. Okay, any other questions? Okay, I think that's it. So go back to Asako-san. Thank you.
Sure. Thank you very much